Okay, let's take a quick spin through area, volume, and surface area. We'll talk about each one of these. Area is going to be more of a review, so let's zip through that really quick. Remember the formulas for area. For a rectangle, it's just area is base times height, or length times width, if that's what you're given. For triangle, remember, it's 1/2 base times height. For a parallelogram, you have to figure out that you can move the parts of the parallelogram around so that it's really a rectangle, so its formula is exactly the same. Area equals BH, or base times height. For a trapezoid, it's a little different. It has one base and then another base that can be different lengths, B1 and B2. So once you know the height of that, your formula then is area equals the sum of B1 and B2, B1 plus B2, divided by 2 times H. And then finally, the area of a circle, when you're given the radius, is pi r squared, the radius squared. Okay, so that's review. Now, let's talk a little bit about volume. First, what is volume again? Well, it's the amount of space that a three-dimensional figure takes up in the world. Okay, and one strategy we can use with many shapes that you'll be given is you can calculate the volume by multiplying the area of the base by its height. So let's look at a rectangular prism, because that's the one you're probably the most familiar with. So here we have a rectangular prism, and we can figure out the area of the base part, and then we can just multiply it by this height. So that would be our formula, volume equals the area of the base times height. But we know the area of the base. It's just a rectangle down here with a length and a width. So we can take L times W, that's the area, and substitute it in here for the area of the base. So our volume formula for a rectangular prism becomes L times W, which is the area of the base, times the height. Length times width times height. How about for a cylinder? Well, same thing. The area of the base times the height would be the volume. But what is the area of that base? If you think about that shape, what is it? If you kind of turned this cylinder on its end, what would you see? Well, you'd see a circle with radius of r. And we know from over here that the area of that is pi r squared, so we can put that in for the area of the base. So volume for a cylinder is pi r squared h. And then finally, let's look at one more a little bit unusual example. This is a triangular prism. It's got a triangle on one end, a triangle on the other end, and then it's got rectangular faces. And its dimensions are length at the base of the triangle and a height here, and then W here as the width of the rectangle on the bottom. But what if we were to tip this triangular prism on its end so that it was resting on one of the triangular faces and its top was the other triangular face? What would we then think about as the base? Yeah, the base would be the area of the triangle, and the height would be which variable here? That's right, it would be W. So we could say that the volume of this triangular prism would be the area of that triangular base times W. And the area of a triangle? That's right, it's 1/2 base times height. In this case, L is the base. So we can say 1/2 LH and put that in for the area of the base. And so the volume for this triangular prism would be 1/2 LHW. So thinking about the base and the area of it and the height can really help you with volume. Now let's talk about surface area. First, a definition here. Surface area is the area of all of the surfaces of a three-dimensional figure. Okay, so one of the things that we can think about here as a strategy is to visualize the surface area of a shape by making nets, by unfolding the shape. So as a good example, let's look at a triangular prism again. Here we have a prism that's a lot like the one that we saw over here. And we want to know the area of every surface here, the triangle in the front, the triangle in the back, this rectangle, the bottom rectangle, the left-hand rectangle. When it's in 3 dimensions, it might be a little bit hard to visualize. But if you think about unfolding it, it'll look like this here. 2 triangles, 3 rectangles. You can calculate the area of each one of those things, and that's how you can find the surface area. Really useful for calculating, for instance, if this was a building or an artistic shape, how much paint would you need to buy in order to cover all of the surface? That's the kind of thing that surface area is for.